Welcome all to today's lecture. Myself, Assistant Professor Tukur Gupta from AKGEC, Ghaziabad. Subject that I am covering in my lecture series is Microprocessor, KCS 403. I am covering Unit 2. Today's topic is Microprocessor 8085 pin diagram. So this is the pin diagram. This is 40 pin IC. All the pins functions have been mentioned here. We can categorize all these pins in the categories of their assigned functions. Like here is power pin, that is VCC, connected to plus 5 volt supply. It is a 40th pin. Here 4th and 5th pin are meant for serial input output signals. SID and SOD, that is serial input device and serial output device. These are interrupt signals, trap, RST 7.5, 6.5, 5.5, INTR and INTA, that is interrupt acknowledgement. So these are all interrupt signals, pin number 6 to pin number 11. Here pin number 3 is reset out, pin number 36 is reset in. So these are reset signals. So our first category was serial input output signals, then interrupt signals, then reset signals. Next is clock signals. To pin number 1 and 2, X1 and X2, that is the crystal is connected. Crystal is used to generate precise clock frequency that is used for the working of microprocessor. This is pin number 37, that is clock out. Here is peripheral initiated signals, pin number 39 hold, pin number 38 HLDA, pin number 35 is ready pin. So these are used to interface the outer peripherals with our microprocessor. I will explain these signals in detail in further slides. Pin number 20 is VSS, that is ground pin. These are pin number 30, 31, 29, 33, 34, 32. This is address latch enable pin. S0, S1 are the status pins. Input output oblique memory bar, read and write, these are the control pins. So all these 6 signals constitute control and status signals. This is address or data bus, that is multiplexed lower order address and data bus AD0 to AD7, pin number 12 to pin number 18. This is higher order address bus, that is pin number 21 to 28, A8 to 815. So we can visualize all these signals as they have been categorized into the types, like serial input output signals, interrupt signals, reset signals, clock signals, peripheral initiated signals, control and status signals, address or data bus, and this is address bus. And these two are under the power supply signals. So this is the pin diagram ranging from pin number 1 to pin number 40, and all these pins have been organized according to their functionalities. Now as we go into detail of pin description, we know that 8085 is the 8-bit general purpose microprocessor and it has 40 pin which uses plus 5 volts power supply. It works at the frequency of 3 megahertz. The pins on the chip can be grouped into 6 groups as I have already told you in this figure. Now when we discuss address bus, so we know that address bus is of 16 bits. So pin number A0 to A7, this is the lower order address bus, and pins that is the signals A8 to A15, these are higher order address bus. Both these A0 to A15, these are all unidirectional lines and these 16 lines constitute address bus. Now when we talk about the data bus, to save the number of pins, to save the hardware, the pin 8085 uses multiplexed lower order address and data bus, that is AD0 to AD7. This is bidirectional in case of data bus and unidirectional in case of address bus. So it can be demultiplexed as A0 to A7 and D0 to D7 according to the requirement. During the execution of instruction, these lines carry the address bus during the early part, that is during the T1 state. When I will explain the machine timing diagrams, then you will get to know that how during the T1 state the multiplexed address and data bus is used as address bus, and during the later part of the machine cycle it is used as the address data bus. Then during the later parts, that is the T2 state, they carry the 8-bit data bus. Now when we talk about the status pins S0 and S1 and ALE, that is address latch enable. ALE pin number 30, it is used to demultiplex address and data bus. So during the part of machine cycle of timing diagram, when the lower order address bus is latched, then ALE is high. So ALE is the positive going pulse generated when a new operation is started by microprocessor, and as soon as this new operation is initiated, so lower order address bus is latched, and during this there is a positive going pulse at ALE. So when ALE is 1, when AD0 to AD7 lines have an address, and ALE is 0 when it is low, and it indicates that contents are the data. The signal can be used to enable a latch to save the address bits from AD lines. Now we come to S0 and S1. These are two status signals which specify the kind of operation that is going on using the microprocessor. So if S0 and S1 both are 0, 0, then the operation going on in the system is halt. Then S1 is 0 and S0 is 1, then write operation is being performed, and this write operation can be with the peripheral, that is the input output ports, or it can be with the memory. When S1 is 1 and S0 is 0, then read operation is being performed. When S1 is 1 and S0 is 1, then fetch, opcode fetch cycle is being executed. So this is how pin signals S0 and S1 indicates the type of operation that is being performed in the microprocessor. Now we come to the pins read, write, input, output, oblique memory. Here in the input, output, oblique memory, this memory part is active low. So now we will discuss read pin, which is active low. Read is active low pin. So whenever the memory or the input output device read operation is being performed in the microprocessor, then this pin is active low, so this pin will be 0. So this signal is activated when it is at logic 0. So when some reading operation is being performed, then this signal will indicate 0. So it indicates that the data is to be read either from the memory or input output device, and data bus is ready for accepting the data. When we are performing the write operation in the microprocessor, then again write pin is active low. So logic 0 at the write indicates that some writing operation is being performed. So it indicates that data on the data bus are to be written to the selected memory or the input output device. Now we come to the input output or memory active low, that is input output oblique memory bar. This signal specifies whether the write or reading operation is being performed with the memory or with the input output device. So if this reading or writing operation is being performed with the memory, or we can say that if any memory related operation is being performed, then this signal is 0, because the activation of memory part is indicated by 0 at this pin, because memory part is active low. And if some input output related operation is being performed in the microprocessor, then this pin is 1. So signal specifies that read write operation related to whether memory or input output device. When input output oblique memory is equal to 1, the address on the address bus is for input output device. And if this is 0, then address on the address bus is for the memory, because some memory related operation is being performed. So we can conclude that input output oblique memory bar, read, write, these three status and control signals indicate some controlling operation. And what is that operation? MEMR, that is memory read. Memory read is indicated when here the memory part is selected, here reading part is selected. So read signal is 0, write signal is 1, and input output oblique memory bar is 0. This indicates some reading operation is being performed on memory. So this is the controlling signal MEMR. Operation is memory read. Again, when this signal is 0, it means some memory operation is being performed, and since it is a write operation, so WR bar is 0 and RD bar is 1. So here the memory write operation is being performed, and the control signal indicated this operation is MEMW, that is memory write. Now again, here 1 indicates that this is the input output operation, here 0 indicates that this is the read operation. So some reading is being going on with the input output device. So input output read operation. Last combination, here some input output operation is being performed, here the writing operation is being performed. 0 at the right bar pin indicates that some writing operation is being performed. So the conclusion is some input output write operation is being done. So this is how the various control and status signals indicates the condition of the operation that is being performed in the microprocessor. So here is the full chart that will indicate one or the other operation being performed in the system. So here 0 indicates that some memory related operations are being performed. Here S1, S1, S0 indicates that what is the status of the operation. So I have already discussed, when S1 and S0 both are 1, the opcode fetch is being performed. Then when S1 is 1 and S0 is 0, then read operation is being performed. And similarly, when S1 is 0 and S0 is 1, write operation is being performed. So let's see this. When both are 1, then opcode fetch is operation. When S1 is 1 and this is 0, the memory read is being performed. Because why memory? Because here 0 indicates that some memory operation is being performed, because memory part is active low. So now here some writing operation is being performed, that is the memory write. Again the same condition follows with input output part. So this indicates input output read, this combination indicates input output write, this combination indicates interrupt acknowledgement, INTA. So and now this is the high impedance state. So whatever the data is here, that is under S0 and S1, this will give halt condition, this will hold, and this is reset. So this is how all the control and status signals indicate one or the other operation, and this is the controlling signals. When we talk about the interrupts, these are the signals initiated by an external device to request the microprocessor to do a particular task, or we can say it will change the flow of program control. So there are basically two types of interrupts, that is the hardware interrupts and software interrupts. Interrupts those are obtained through the hardware pins are known as the hardware interrupts, and interrupts that are being operated using the programming, that is known as the software interrupts. So since we are discussing the pin diagram, so here I will discuss the hardware interrupts. So trap is the first and foremost interrupt, and this is having the highest priority. This is also non-maskable. So here priority is going like this. So this is having the highest priority, and this INTR is having the lowest priority. RST 7.5, RST 6.5, RST 5.5, these are arranged priority wise, and lastly the INTR. So all these interrupts except the trap are maskable, and you can allow or disallow these interrupts. INTA is the interrupt acknowledgement. When some interrupt arrives on the system and the system accepts that interrupt and that interrupt is being executed, then interrupt acknowledgement signal is sent from the microprocessor to the device sending that interrupt. So in this way, this is the interrupt acknowledgement signal and this is the active low. This is basically an output signal from the microprocessor. So when we talk about the power supply and clock signal, so I have already discussed that pin number 40 denotes the plus 5 volts power supply and pin number 20 is ground. So there are three important pins in this group. Pin number 1 and 2, these are the pins to which the crystal oscillator is being connected. The frequency of microprocessor 8085 is internally divided by 2. So since the basic operating frequency is 3 megahertz, so we have to connect a crystal of 6 megahertz, then only after being divided by 2 we will obtain the frequency at 3 megahertz. So the cause of using the crystal oscillator for generating the clock frequency is that the crystal oscillator is a very precise device and it will give the most accurate signals, most accurate clock signals. Clock out, that is it is used as the system clock for peripheral device and the device is interfaced with the microprocessor. So through this pin we can use the clock for other peripheral devices which are connected to the microprocessor. Reset in is the active low input pin. It is used to reset the microprocessor, and on the resetting of microprocessor the program counter is set to 0000H, that is the PC. Buses are tri-state. This is the condition after the system is reset. And what is the purpose of reset out? This is the output pin and also active high, and it is used to reset all the connected devices when the microprocessor is reset. So it indicates that the microprocessor is being reset and it will reset all the peripheral devices also. When we talk about the DMA operation, when two or more devices are connected to a common bus to prevent the devices from interfering with each other and to reduce the CPU time. So the CPU controls the data transfer operation between the memory and input output devices. So in the DMA operation, the peripheral devices can access the memory without the CPU intervention, and this is how the peripheral devices can be directly connected to the memory and they can directly access the memory. So this is why this is known as the direct memory access, DMA. The CPU is disabled by tri-stating its buses and transfer is effected directly by external control circuits. So here, what is the purpose of hold pin? Hold pin, the signal on this pin indicates that another device is requesting the use of address and data bus. So the microprocessor will relinquish all the buses as soon as the current machine cycle is completed, and after this the microprocessor regains the bus after the removal of hold signal. So when the hold signal arrives on the microprocessor, it means that some request from the external device has arrived on the system to relinquish the buses. So hence the microprocessor will acknowledge the request and will relinquish the bus and will give the hold of the buses to the peripheral device. So this is how it is done, and HLDA receipt of the hold signal, the microprocessor acknowledges the request by sending out the HLDA signal and leaves out the control of the buses. After the HLDA signal, the DMA controller starts the direct transfer of data. After the removal of hold request, HLDA goes low. So this is how the HLDA and hold pin are the complementary to each other and they are used for the DMA operation. Now when we talk about the serial input output signals, this is the serial input data line. It's used for accepting the data serially. The data on this line is loaded into the accumulator bit 7 whenever the RIM instruction is executed. So when I'll explain all the instruction set, then we will go into detail of RIM and SIM instruction. It is a data line for serial output, that is SOD, serial output data. It is used to transmit serial data bit by bit to the external device. The 7th bit of the accumulator is outputted on the SOD line when SIM instruction is executed. So we will go into details once we study the SIM and RIM instructions. Then we talk about ready pin. So when we are connecting some peripheral devices with the microprocessor and those peripheral devices are slow as compared to the speed of microprocessor, then after completing the present job, such a slow peripheral may not be able to handle further data or control signal from CPU. Then what will happen? The processor sets the ready signal after completing the present job. It synchronizes the slow peripherals to the processor. So when there is a signal on the ready pin, the high signal on the ready pin indicates that the processor is ready to establish the communication with the peripheral device, which is slower as compared to microprocessor. And then microprocessor enters into wait state while the ready pin is disabled. So basically the ready pin is used to synchronize the slow peripherals with the microprocessor so that a smooth transition of data between the slow peripheral and the microprocessor can take place smoothly. So this is how all the signals have been discussed in today's lecture, and in further lectures we will study other parts of 8085. Thanks a lot.